Jai Hind everyone. Welcome to the class of Microprocessor. Under Unit 5, this is the new video lecture. The topic for this video lecture is Intel 8259 or Intel IC 8259, which is also known as the Programmable Interrupt Controller. So in this lecture, we will discuss the Intel IC 8259 in detail. Intel IC 8259. Basically, this is a special purpose IC that has been designed by the Intel company for handling the interrupt request for the 8085 microprocessor as well as for 8086 microprocessor. So this IC can be used with any Intel microprocessor like Intel 8085 and Intel 8086. So basically this Intel IC 8259 handles the interrupt request for these microprocessor 8085 and 8086. This IC Intel 8259 is basically an 8-bit IC. That is, it can handle 8-bit data transfer between the 8259 and the microprocessor 8085 or 8086. So we can see that in the IC 8259 we will have data lines D0 to D7 because this is a 8-bit IC. Now, what is the main purpose of this IC? This IC is known as Programmable Interrupt Controller. Sometimes this is also known as Interrupt Priority Controller. Interrupt Priority Controller. As clear from the name, basically this IC handles the interrupt request for the 8085 and 8086. So this is known as interrupt controller, and whenever multiple interrupt requests are received from the attached peripheral devices, this Intel IC 8259 also act like the priority controller or also known as the interrupt priority resolver. That is, whenever multiple interrupt requests of same level are received by the microprocessor through the attached peripherals, then what will be the priority? Which interrupt will be executed first? Which will be executed after that? That is decided by this IC Intel 8259. That's why this is known as interrupt priority controller as well as also known as the interrupt resolver, interrupt priority resolver. Moreover, this is a programmable IC. This is a programmable IC. Programmable means the operation of this IC can be controlled by writing the command word. By writing the command word register, that is popularly known as CWR. Okay. So in the Intel IC 8259, there will be registers known as command word registers, that is CWR registers. According to the assigned values in this CWR register formats, the IC 8259 will work accordingly. This is known as the programming of the 8259. That is, writing values or assigning values into the CWR format so that the IC 8259 will work accordingly. This is known as programming. So that's why this is known as Programmable Interrupt Controller or Programmable Interrupt Priority Controller or Priority Resolver. Another feature is that this IC 8259 this IC 8259 can also be used for increasing the interrupt handling capability. It can increase the interrupt handling capability. Interrupt handling capability of the microprocessor can be increased with the help of this IC 8259, because the individual 8259 IC can handle 8 interrupt requests from the attached peripheral devices or IO devices. So single 8259 can have 8 interrupt requests from the attached devices or peripherals. These requests are IR0 to IR7. Whereas when we talk about the microprocessor, in the 8085 there are 5 hardware interrupts. Whereas when we compare to this 8086 has only 2 hardware interrupts. So 2 hardware interrupts are basically non-maskable interrupt, NMI, another is maskable interrupt, INTR. So if we talk about maskable interrupt requests, the Intel 8086 microprocessor has only one interrupt request input pin, that is INTR. So that means microprocessor Intel 8086 can handle only one interrupt request which is maskable at this pin INTR. But in practical situation, it can happen that multiple interrupt requests may be received over the microprocessor Intel 8086. So if multiple interrupt requests are received, and it may happen that the level of these received interrupt requests may be the same. So there is how the priority can be decided by this 8086 microprocessor. That task is done with the help of this 8259. So basically 8259 will receive the multiple request IR0 to IR7, and based upon the operating mode, for example nested mode, nested or fully nested mode. Another mode can be automatic rotation mode. So based upon the mode, that is fully nested mode for example, another is automatic rotation mode. Based upon the mode, this 8259 will resolve the priority or will decide what will be the highest priority for these interrupts. So let's say 8259 decides that this IR3 will have the highest priority. Now 8 requests were received, but out of these 8 requests, the priority has been resolved by 8259, and it said that the IR3 request will have the highest priority. So now this IR3 will be connected to the INTR pin of the 8086 microprocessor. So in earlier case, if we use directly, then only one interrupt request was handled by the 8086. But if we handle the interrupt request through the 8259, we can have 8 interrupt requests handled by the 8086. Moreover, this IC 8259 can also work in the cascade mode. That is, multiple 8259 can be connected with each other. So in this case, we can have 8 8259 connected with each other. So if 8 8259 are connected with each other, we can have 64 interrupt requests. So with the help of cascade mode, the interrupt handling capability of microprocessor 8085 or 8086 can be increased up to 64 interrupt requests, and their priority will be resolved by the 8259. Moreover, these interrupt requests received over this INTR pin or INTR interrupt, this is a non-vectored interrupt. That is, ISR address for this interrupt request received over the INTR pin is not specified. So, the interrupt vector address for these non-maskable interrupt requests can also be generated by this IC Intel 8259. Okay. This is the general interfacing diagram where we connect the microprocessor 8085 or 8086 with the Intel IC 8259. So basically, these are the multiple interrupt requests which are received from the different or attached peripheral devices or IO devices, or these interrupt may be request may be of same level. This IC 8259 is 8-bit IC. So these 8 lines are connected with the 8 data lines of the microprocessor 8086. So D0 to D7 is connected with the AD0 to AD7. These data lines will help in transferring the interrupt and its type or related data to the microprocessor. Now, this Intel IC 8259 interrupt priority controller will have an interrupt output pin. It has single interrupt output pin. To the 8259, we have received 8 requests. Out of these 8 requests, the priority is resolved by this 8259. Let's say the priority is highest for the interrupt request 3. So interrupt request 3 will be connected with this INT output pin, and that INT pin will be connected with the corresponding INTR pin of the microprocessor, that is maskable interrupt pin, hardware pin of the 8086. So whenever the interrupt request is received over this INTR pin, acknowledgement for the same is given through the INTA pin. So this INTA will be, for acknowledgement purpose, will be connected to the INTA of the 8259. So in this way, the 8259 can be interfaced with the 8086 or 8085 microprocessor. Let's discuss some general features of this IC 8259, although we have covered, but these are in points. So this single IC 8259 can manage 8 interrupt requests. Okay. So in the case of 8086, where we have single interrupt pin for maskable interrupt INTR, if we use 8259, it is similar to providing equivalent 8 interrupt pins. So that is, interrupt handling capability of the microprocessor can be increased. In the previous slide, we have also discussed that this INTR interrupt is a maskable interrupt and is also a non-vectored interrupt. Okay, so non-vectored interrupt is there. So the vector address for these interrupt requests are also generated with the help of this 8259. So in the vector address, we can have a choice of having a gap of 4 locations or 8 locations between the ISR addresses. So in the mode, in the CWR, whether we want gap of 4 memory locations or 8 locations between the ISR addresses, that can be selected. Moreover, we have discussed 8 level of interrupt priorities in variety of modes, that is 8259 resolves the priority of multiple interrupt requests based upon the modes. These modes are, for example, we have discussed fully nested mode, another is automatic rotation mode and specific rotation mode. We will discuss these in later. So based upon the mode, we can have a priority deciding mechanism in the 8259. Based upon that, multiple interrupt requests are received in the microprocessor based system, then their priority gets resolved. In the 8259, we also have another feature, that is we can mask the each interrupt request individually. Okay. In the multiple interrupt request system, it is also possible that we want to give request or service to interrupt or not. That is basically in the microprocessor based system, there is a concept of maskable interrupt and non-maskable interrupt. Non-maskable interrupt is NMI, where the service to the interrupt request cannot be avoided or delayed. Whereas in the case of maskable interrupt, service to the interrupt request can be avoided or delayed. So if we want to avoid the service to particular interrupt or want to delay the request to that particular interrupt, we can have the feature of masking the interrupt request. So using the 8259, we can mask the each interrupt request individually. Okay. Next is, in the 8259 also, we can have different type of registers. Based upon that, we can know what is the status of interrupts or at what stage the interrupt requests are being lying, whether they are pending, whether there is any interrupt that is pending for service. In service interrupts, that is the interrupts which are currently being executed, and what are the masked interrupts that have been selected for avoiding or delaying the service to those interrupt requests or which have been masked. This IC Intel 8259 has another advantage, that it can accept the interrupt request whether the interrupt request signal is a level triggered or an edge triggered interrupt request. That is, it recognizes both level of triggering, that is level triggered and edge triggered. If interrupt request is received in the triggered form, that is also accepted, and if it is received using the level triggering, that is also accepted for service. Next is, it can be extended up to 64 priority levels by using the cascade mode. We have discussed that the 8259 can work in the cascade mode, where multiple 8259 can be connected with each other. Out of these multiple 8259 ICs, one of the IC will become the master and remaining will behave as a slave. So in the master slave mode, we have the multiple priority interrupt requests are connected. So if we use single 8259, we can have 8 interrupt requests, and if we connect 8 8259, then we can handle up to 64 interrupt requests. That is, the interrupt handling capability can be increased up to the level of 64. More importantly, this Intel IC 8259 can work either with the 8085 microprocessor or can also work with the 8086 or 8088 microprocessor. Let's discuss the general block diagram or internal architecture or internal block diagram of this IC Intel 8259. As we have discussed the interfacing of this IC 8259, so this section D0 to D7 will be connected with 8085 or 8086 microprocessor. So on the left hand side, we connect the microprocessor 8085 or 8086. Then these data bus buffer are used to carry the 8-bit interrupt data and type of interrupt between the microprocessor and 8259. So basically these are the data lines of 8259 which are connected with the AD0 to AD7 of microprocessor. Then another block is there, read write logic. Basically this read and write, these are used for deciding the direction of data flow. Direction of data flow between the microprocessor and the attached peripheral or maybe with the 8259. Then A0, address line 0 is used while programming the CWR or command registers. Okay. For example, we can see that in the 8259 we have different command word formats ICW and OCW. So in the ICW and OCW, this A0 will be used for assigning the values depending upon which type of mode we want to work in the 8259 IC. Then this CS bar chip select pin is known as the enabling pin, or to enable this IC for any operation, we have to apply logic 0 over this chip select pin. Then we have cascade mode or the buffer mode. Okay, we have discussed that for increasing the interrupt handling capability, the IC 8259 can work in the cascade mode where multiple 8259 are connected with each other. So in that case, these cascade pins are used. And these pins are also used for selecting the program like slave program and enabling the buffer mode. So 8259 can work in the cascade mode or buffer mode. So in the cascade mode, we have to use the master slave configuration. So SP is used as the slave program, and whereas EN pin is used for selecting the or enabling the buffer mode. Now inside this architecture related to interrupt request, these are the multiple interrupt requests IR0 to IR7 which are received from the attached devices. So in the 8259 there are three important registers: IRR register, in service register and interrupt mask register. All the interrupt requests which are coming are handled by this or stored in this interrupt request registers. This IRR register stores or handles, receives the all interrupt requests which are received by the 8259. Now this block priority resolver will decide which interrupt will be the highest priority interrupt, which will be the least priority interrupt. This priority resolver will resolve the interrupt priority based upon the mode, like fully nested mode, automatic rotation mode, specific rotation mode. Okay. Then we have in service register. The interrupt request which has the highest priority, that will be executed first, or the current request which is being executed or is being processed now, that will go into the in service register. Then according to the in service register, that interrupt which has the highest priority or currently being executed, that will be connected to this INT output pin, which is connected to the INTR pin of 8086 that we have seen in the interfacing diagram. This INT will be connected to INTR of 8086 and acknowledgement for the same will be received over this INTA bar pin through the INTA bar pin of the microprocessor. Then this block, interrupt mask register, as we have discussed, we can have some interrupts for which we don't want to give the service or execute those interrupt requests. So the interrupt number for those masked interrupts can be kept in this interrupt mask register. These are the important blocks present in the 8259 IC, which is interrupt priority controller or programmable interrupt priority resolver. Main blocks that we have discussed. Data bus buffer, it is connected with the 8-bit address and data lines of the microprocessor through the D0 to D7 of 8259, that is D0 to D7 of 8259 is connected with the AD0 to AD7 of microprocessor, that can be 8085 or 8086. Again, read write control logic, this is used for handling the or deciding the direction of data flow. Okay, and this will work when the chip select pin is enabled, that is CS bar pin is connected with logic 0. So direction of data flow will be there. Then we have control logic. It controls the entire operation of 8259, where this interrupt, maskable interrupt pin of hardware microprocessor 8086 is connected with the single output INT pin of the 8259, which has been received after deciding the priority in the 8259. These are the main important registers present inside the 8259 architecture. That is, first is interrupt request registers, that is IIR, as we have discussed in the diagram. Interrupt request register is basically used for storing the all interrupt requests in the microprocessor. Then interrupt service register or in service register, basically the interrupt request with highest priority or the interrupt that is being currently executed, that is stored by this in service register. Next we have interrupt mask register. Basically it stores the interrupt level that will be masked or that has been stopped from executing. It can happen that we want to avoid the service to a particular interrupt request, so that interrupt request need to be masked. So the interrupt number of that interrupt which is to be masked is stored in this interrupt mask register. Then we have a priority resolver. Priority resolver basically, depending upon the modes, will resolve the priority out of multiple interrupt requests which may be of same level. So we have to decide the priority. So priority is decided according to the mode. So based upon the selected mode, we can have the priority. Priority is basically resolved by this priority resolver. So the interrupt with highest priority will be sent to the in service register and will be executed. Cascade buffer, as we have discussed, the 8259 can work in the cascade mode, where multiple 8259 are connected with each other for handling the more than 8 interrupt requests. So for that purpose, we have used cascade lines in the 8259, whereas along with this 8 CAS line, we will also have the slave program oblique enable pin that will be used for either selecting the cascade mode or selecting the buffer mode, or enabling the 8259 IC for the buffer mode. This is the pin diagram of Intel IC 8259. Intel 8259 is designed as a 28 pin IC, and the package for this IC is DIP package, dual inline package. That is, these 28 pins are divided into 2 lines, each of 14 on both sides. So this is the pin diagram for IC 8259. So that's all for this lecture. Thank you everyone. Jai Hind.